Hey everyone, and welcome to this explainer. If you're like most people, you probably look at SpaceX and see, well, a rocket company, right? A company focused on launching satellites, building internet constellations, and eventually getting humans to Mars. But today, we're going to challenge that assumption completely. Because if you really dig into the data, look at their recent mergers, and break down the underlying economics, SpaceX is rapidly transforming into something else entirely. It is quietly becoming a massive artificial intelligence infrastructure conglomerate. $1.75 trillion. Yeah, that's trillion with the T. That is the staggering estimated combined valuation of the newly merged SpaceX and xAI conglomerate. And honestly, you have to ask yourself, why on earth would a rocket launch provider absorb a cutting-edge artificial intelligence lab? Like, what business does a space company have integrating with the team building neural networks? It's a huge move. It sends shockwaves through both the tech and finance worlds, and the reasoning behind it is absolutely fascinating.
The absolute core of this entire strategy is summed up perfectly by this quote from Elon Musk. He recently pointed out that the electricity demand for AI on Earth simply cannot be met with terrestrial solutions in the long term, at least not without imposing severe hardship on local communities and the environment. And this right here is the massive paradigm shift we need to wrap our heads around. All those rockets and Starlink satellites you see launching every single week, they aren't just for internet access anymore. They are essentially Trojan horses for building the ultimate unconstrained AI cloud right above our heads. Okay, let's dive into Section 1, the hidden AI conglomerate, merging rockets and neural networks.
By combining SpaceX's absolute dominance in launch capabilities with xAI's massive, and I mean massive, computational needs, they are forming a vertically integrated AI monopoly. They aren't just sharing a few engineers or resources across companies. They are building a completely self-sustaining loop. The company that desperately needs the compute now owns the absolute cheapest way to deploy that compute into a limitless environment. We really need to flip our mental model here. The rockets are just the delivery trucks. The actual product being sold, it's AI tokens. Think about it like Amazon Web Services renting out cloud compute on Earth. SpaceX is uniquely positioned to build actual token factories in orbit. The end goal isn't just getting hardware to space anymore, it's generating the computational power for the next generation of artificial intelligence and beaming those outputs right back down to Earth.
Moving on to Section 2, Earth's artificial intelligence bottleneck and the terrestrial limits of compute. We are literally hitting a brick wall right now with terrestrial AI data centers, and it's not a software glitch, it is a hard, physical limit dictated by power generation, massive water consumption for cooling, and just running out of usable land. To put this into perspective, the entire average power grid capacity of the United States sits at around 460 gigawatts. But the projected power demand for large-scale AI, that is barreling toward 300 gigawatts. Think about that for a second. That means AI alone would gobble up 2/3 of the entire country's electricity production. And if we push toward a 1,000 gigawatt or a 1 terawatt AI demand, it's literally impossible on Earth. We simply cannot build power plants fast enough to support that kind of drain.
Think about the contrast here. On Earth, AI is basically fighting a losing battle against local power grids. To cool down these giant racks of GPUs, we are evaporating millions of gallons of fresh water, which, as you can imagine, is already causing serious environmental pushback. Plus, you have endless zoning red tape to deal with. But outer space? Space offers absolute abundance. You have continuous, unfiltered solar energy. You can use the deep vacuum of space as a massive, infinite heat sink to cool your hardware. And best of all, for these companies, there are virtually zero local permitting or zoning laws holding back your expansion.
Which brings us to Section 3, the orbital compute solution, or harnessing the vacuum.
So, if the huge bottlenecks on Earth are power and cooling, the physical properties of space actually solve both of these crises at the exact same time. It all comes down to something called a sun-synchronous orbit. Basically, by placing a data center satellite in an orbit that constantly rides the dawn-dusk line of the Earth, you achieve 24/7 continuous solar exposure. You literally never enter the Earth's shadow. That means zero atmospheric interference blocking the sun, and incredibly, you don't even need heavy, expensive batteries to store power for the night. Why? Because there is no night. It represents the absolute lowest potential power cost anywhere in the solar system.
Now I know what you're thinking. This sounds like pure science fiction, right? But let me be super clear, it's not. A startup named StarCloud has already proven this concept actually works. They recently launched a satellite carrying a standard terrestrial NVIDIA H100 GPU straight into orbit. And it proved that Earth-grade hardware can absolutely survive the thermal and vacuum challenges of space. And they aren't stopping there.
By late 2026, they plan to launch a satellite 10 times more powerful. And by 2030, we are looking at massive, interconnected space AI clusters being deployed by multiple major players.
All right, Section 4, Starship Economics Unlocked. Let's look at how they are making the math work.
You might be wondering, well, why didn't we do this 10 years ago? The physics of space haven't changed, right? True, but the economics have. This entire business model completely hinges on drastically reducing launch costs. With a traditional Falcon 9 rocket, it costs about $2,750 per kilogram to launch a payload into orbit. At that price tag, orbital data centers are just way too expensive. The financial models show that the break-even point is roughly $500 per kilogram. But Starship changes the whole game. Because it's designed for full reusability, Starship is targeting a launch cost of just $200 per kilogram, and eventually they want to get that down to $10 or $20. Once you cross that $500 threshold, orbital computing doesn't just become viable, it becomes highly profitable.
Let's put a real dollar value on what that kind of launch efficiency buys you. $30 billion. According to financial analysts, deploying a massive 1 gigawatt data center in space using Starship would cost roughly $30 billion. Now, if you wanted to build that exact same 1 gigawatt facility down here on Earth today, you're looking at $60 billion. Why? Because of the staggering sky-high costs of building massive new power infrastructure and insanely complex water cooling systems. Space is literally half the price.
Section 5. Inference over training. Let's dig into how space AI actually works in practice.
We definitely need to clarify what kind of AI is actually going into orbit, because you can't just throw any random computing task up there. Space has very strict realities when it comes to bandwidth and radiation. The secret here is understanding the difference between training an AI model and running AI inference. Training a massive new AI from scratch requires absolute terabits of bandwidth and is super vulnerable if a stray cosmic ray happens to flip a bit of data during the process. Inference, on the other hand, which is basically just asking an already trained AI a question, requires very low bandwidth for those short little prompts and is highly viable using simple error correction. So these orbital data centers, they are focused heavily on inference. You do the heavy lifting of training the model on Earth, and you deploy it into space to actually answer the world's queries. And honestly, the engineering workarounds for the orbital environments are brilliant. It turns out that standard off-the-shelf AI chips are actually surprisingly radiation-hard right from the factory. That occasional data glitch from a cosmic ray, it's easily managed by standard error-correcting code software. And as for maintenance, well, there is no maintenance. If a piece of hardware fails, you don't send a mechanic up to fix it. You simply replace it every few years, exactly like they already do with Starlink satellites. And all the actual data, all those user queries, are just beamed up and down at lightning speeds via highly focused laser optical links.
Finally, Section 6, the sovereign compute race. Geopolitics above the atmosphere.
Look, a multi-trillion-dollar opportunity like this doesn't exist in a vacuum. Pun absolutely intended. SpaceX is for sure not the only player looking at this space. The geopolitical implications here are massive. Sovereign nations and megacorps are quickly realizing that an orbital data center can bypass terrestrial export controls and local land restrictions entirely. China, for instance, is actively planning a massive 2,800 satellite three-body constellation strictly for computing. The U.S. defense sector is already working with companies like Axiom Space to build secure orbital nodes. And big tech giants like Google, with their Project Suncatcher, alongside Blue Origin, are all rushing to stake their claims. We are looking at a completely neutral, borderless race for the ultimate computing high ground.
This whole global rush really shows the true scale of what's unfolding right in front of us. The transition of humanity's most powerful, energy-hungry infrastructure from the ground up into the vacuum of space. It isn't some distant sci-fi fantasy anymore. The rockets are already launching and the economics are aligning right now. But it does leave us with one very profound and frankly pretty provocative thought to chew on. Who exactly controls the internet? And who controls the future of artificial intelligence when the cloud is literally up in the stars? Thank you so much for joining me on this explainer. Keep looking up and keep questioning what's possible.